Every time you turn on a light, unlock your phone, or stream a video, you're using one of the most important inventions in human history. It's smaller than a grain of rice, and it changed the world. This is a transistor. Think of it as a tiny electronic switch or a controllable valve for electricity. It has three parts: the base, the collector, and the emitter. And when you put billions of them together on a single chip, you get the brain of every computer, phone, and smart device on Earth. Here's the simplest way to understand it. Imagine a water faucet. A tiny twist of the handle controls a huge flow of water. A transistor works the same way. A small electrical signal at the base controls a much larger current flowing between the collector and the emitter. That's how it can act as both a switch and an amplifier. Before transistors, electronics relied on big, fragile glass tubes that got extremely hot. Transistors changed everything. They made devices smaller, faster, cheaper, and more reliable. Without them, we wouldn't have personal computers, smartphones, the internet, or almost any modern technology. Take the phone in your hand right now. Inside it, billions of transistors are switching on and off millions of times every second, deciding which pixels to light up, which sounds to play, and which apps to run. That's the power of the transistor, invisible but everywhere. So the next time you turn on a device, remember, it's all possible because of a tiny switch that can control electricity with incredible precision. The transistor, small switch, big impact. Not all transistors are the same. There are two main types you'll see everywhere: the NPN transistor and the PNP transistor. They look similar, but they work in opposite ways. The difference starts with how they're built. An NPN transistor has a thin layer of p-type material sandwiched between two n-type layers. A PNP transistor is the opposite, a thin n-type layer between two p-type layers. That middle layer is the base, and it's the key to controlling the current. Here's the biggest practical difference. In an NPN transistor, a small positive voltage at the base allows current to flow from the collector down to the emitter. In a PNP transistor, it's the opposite. A small negative voltage at the base allows current to flow from the emitter up to the collector. Think of them as opposite switches. One turns on with a positive signal, the other with a negative signal. Imagine two water valves. The NPN is like a valve that opens when you push the handle one way. Water flows down. The PNP is the reverse. It opens when you push the handle the other way and water flows up. Same job, opposite direction. So why does this matter? NPN transistors are more common in most digital circuits and amplifiers because they're usually a bit faster and easier to use with positive voltages. PNP transistors are often used when you need to switch power from the positive side of a circuit, what's called high-side switching. Knowing the difference helps you choose the right one for the job. To sum it up, NPN and PNP transistors are opposites. One turns on with a positive signal at the base, the other with a negative signal. Same basic idea, controlling a big current with a small one, just in reverse directions. That's the key difference between NPN and PNP.